Okay, so let's continue. In today's class, we are going to start with the that preparation of alkyl halide by the halogen exchange there, and the very first is going to be the Franklin reaction there, and second is going to be the Schwarz reaction. Okay, so basically there's a two reaction for you. Okay, and for these kind of reaction, mechanism is not required, only reaction is required there. Okay, thank you so much. Okay. Okay then, so let's continue further. That is a Franklin reaction. This reaction is important for the preparation of alkyl halide. Okay, it is important for the preparation of alkyl halide there. Okay, alkyl halide, which halide only? That is iodide. That it is famous for the iodine formation there. So let's see how the reaction look like. So observe this point here in a Franklin reaction there. That how the reaction is going on. Let's just suppose I'm having some kind of chlorine. Let's say okay, and in this case, if let's suppose this is my iodine, so this iodine basically replace this chlorine from there, and we are getting this is Ri and Cl negative evolved out. Okay, so this is an equilibrium reaction. Simple. I guess the simple already clarify the point that it's a equilibrium process there. And now my question to you, that okay, this given Rx can be, it can be Cl, it can be bromine, or it can be fluorine, but why not iodine? Okay, means maybe this question arises in your mind, ma'am. See, okay, that chlorine combined with iodine, okay, bromine combined with iodine, so every time we are end up with only the same thing, that is the Ri there. But question be like that why not this reaction is important for the chlorine formation, bromine formation, or fluorine formation? Do you know the answer for this question? Wants to try? Okay, so let's find out the answer for this question. Do you know in this reaction basically what is going to happen there? First of all, listen, this one, if you are having some Rx, okay, this X can be chlorine, this X can be bromine, or this X can be fluorine there. Okay, and if you are using iodine, okay, so basically what we are using, do you know that is NaI? Okay, that is a sodium iodide. So here you're using NaI, and we are using here dry acetone. I said dry acetone. Okay, dry acetone, and yes, you have to use sodium as well. That sodium in the presence of dry acetone. Observe the reaction one more time. That is NaI in dry acetone. Okay, so first question, what is the use of this dry acetone? What is the use of this dry acetone here? Why not aqueous? Why not water? Yes, please. Catalyst. You know, sodium, water, Aditya? No, it's not like that. Okay. Yes, please, Shrivardhan. Because here
Ma'am,
we,
you're a bit lagging.
yes,
Ma'am, you're a bit lagging.
I'm lagging. Is the same problem with everyone?
No, ma'am.
Okay. So just refresh once, Vardhan. Okay, maybe some problem at your end. Okay. So let's continue. What we're discussing here, that in this reaction, the dry acetone, why we're using a dry acetone? Because the answer is very simple. Because here we are having a sodium. Sodium is there, and you know very well if you to use the water, so sodium has a very highly explosive reaction with the water. That's why we have to avoid the use of water. Only dry acetone we are going to use. Now, next question for you. If okay, next question, is this going to follow the SN1 mechanism or SN2 mechanism? Yes, please. SN1 or SN2? Which mechanism basically we have to follow there? It's not like we are discussing all this thing today and you forget about the previous class. Yes, please. Is it SN1 or SN2? Okay, okay. SN2, SN2. Okay, so yes, it is going to follow the SN2 mechanism. Why SN2 mechanism? Because we are using acetone, and in the previous class we discussed about it is a polar aprotic solvent, right? So it's a polar aprotic solvent. So that's why it is going to follow the SN2 mechanism. So be noted. Maybe somehow the question asks the SN1 mechanism there or SN2 mechanism there. Again, we are not going to follow the mechanism because mechanism part is not that much important here. So we are using a polar aprotic solvent. Okay then, cool. So that's it. But again, the same question that why we are using only NaI. why we are not using NaBr, why we are not using NaCl and even NaF as well, that why we are using only the NaI there. So answer is very simple. Do you know actually what is going to happen in this case? You are using acetone. So this NaI, okay, this NaI is soluble. Listen, this is the answer for this question, that why we are using only this, why not all three. So what is the answer for this question? The answer is very simple, that just because of NaI is soluble in acetone, soluble in acetone. So, you know, in organic chemistry, how we have to proceed. First of all, we are making a clear solution. Then we are adding some reagent, so that there's a no problem with the reaction. Okay, cool. And then what is going to happen there? Then there is a formation of some Ri, and maybe there is a formation of NaBr, there is a formation of NaCl, there is a formation of NaF. Okay, we are taking every halogen and they precipitated. Okay, these three precipitated in acetone. Okay, precipitated in acetone, or you can say that is insoluble, basically insoluble. Right, this is a simple meaning. It is insoluble in acetone. Now question, if it is insoluble in acetone, then what is going to happen there? So now there's a question for you. Let's just back here. According to the Lee-Chatterjee principle, can you just tell me, if this side, if in the product side the precipitation take place, so reaction going to move the moving toward the that is a forward direction or a backward direction? Yes, please. If in a equilibrium reaction, the precipitation toward the product side, so we have to follow the reactant side or a product side. Think about, apply the Lee-Chatterjee principle there. Forward, backward, backward, backward. Okay, so let me just explain like this. So many variations. Okay, so listen my point. Basically, what is happening there, that in this reaction, okay, in this reaction, if we are going to follow, this is my Rx, okay, and this is I negative, and there is a formation of RAI and some precipitation there. Okay, this is some NX dash, it's going to precipitate, and be noted, it can be the chlorine, it can be the bromine, or it can be the fluorine as well. Okay, so it is precipitated down, so equilibrium is there. So basically what is happening, if precipitate form, what we are doing, we start removing this, right? If precipitate form, so precipitation means that this thing is not soluble further. Okay, if this thing is not soluble further, so think about it, that I'm giving you two condition. Okay, this is my water. In this water we are adding sugar there, let's say. Okay, sugar. So if you to keep adding sugar and sugar and sugar, precipitation take place. Remember, that is a Ksp value, that saturated point where precipitation have to be there. If the Ksp exceed there, so it means precipitation is there. Yes, precipitation is there. So you can say this side, if you to compare this and this side, here we are having a solution, and this side we are having some solution as well. So which side we are having less number of solution? You can say forward side. Basically, if precipitation is there, we start removing that product from outside, and hey, that we are reducing the product side. So basically, the reaction follow the forward direction. It is the key point. In order to increase the rate of reaction, we are using that this reaction only for the fluorine, sorry, iodine part there. So let's see the reason behind this. So observe this. First of all, this is a general reaction there. You are having some NaX, NaI, combined dry acetone. We already covered why we are using dry and acetone as well. And then Ri, NaX precipitate down. This is some example. You are using some alkyl bromide. Okay, this is nothing. It's a that is a bromomethane, you can say. So let me just write the name. It is going to be the bromomethane. Okay, so it's going to be the bromomethane. And please, it's a request to everyone. Please join on a time, okay? So bromomethane. So it's combined with Na, dry ether, and we are end up with this, okay? And it's precipitate down. Let's see the reason that why we are using only the iodine there. So sodium iodide in dry acetone can be used as a test for primary bromide or chloride as well. Okay, now can you just tell me how we can identify there? Answer, line of precipitation. You know, if you are having the precipitation of NaBr, or if you are having a precipitate of that is a sodium chloride. So doing the color, recall the Lassan's test and all these things. Yes, please. You know the color for NaCl. You know, most of the time chlorine, when chlorine came to the picture, so which kind of color we are getting? Options: white color, or that yellow color, white color. right? So yes, white color is there, and you can compare with the salt there. So if white color precipitate we are getting, so it is confirmed that NaCl, and even we can check it for the NaBr as well. Okay, this is very simple. Sodium iodide in dry acetone can be used as a test for primary bromide or chloride. Since it follow the SN2 mechanism, I hope this point is clear for everyone. Why SN2 mechanism? Because we are using acetone. Acetone is a polar aprotic solvent. If you don't know what is SN1, SN2, how to proceed with SN and SN2, please watch the recorded classes of that reaction intermediate. Okay. For primary halide, it means that in this reaction, if let's suppose I will give a kind of question, this is a question for you. If you are having CH3, thrice, and bromine, okay, you can say it's a. Or let me just use that as a, this is simple, be there. So who is going to react first? In the same reaction. Yes, in both the cases, we are using sodium iodide in the presence of acetone. Yes, please, who is going to react first? Is it A or is it B? A. Okay, Vaibhavi. A. A. Okay, so which mechanism we are going to follow here? Yes, please. SN2, right? We just discussed about this. So SN2, remember it's a single step reaction. There is a no a positive charge form, right? No need to stabilize the positive charge. So just because in order to remove the hindrance, we are using primary alkyl halide, right? Yes, very good. It is going to be the B. If you are doing still, the problem is there, okay? Okay, this is the correct answer, option number B. Because we know the order of the SN1, SN2 mechanism there, that in SN2 mechanism, we are going to follow that is tertiary, react less, then secondary, and then primary. We already covered these things in very much detail. Okay, then this is all for the reaction. Let's continue further. Now let's just talk about the next one. Like the Franklin reaction is important for the iodine formation of iod that is halo alkane part in case of iodine only. Same here. Swart reaction is important for the fluorine. Yes, Payal.
Ma'am, can you show me the last slide once?
Mm-hmm. Of course. This is the last slide. Once again, okay, Mohana, let me just explain in a very brief, but again, please watch the previous classes, okay? It is a huge chapter, but let me just quickly explain what is SN1 and SN2 mechanism. So let's just discuss about SN1 and SN2 mechanism there. Okay, then let's discuss about this. So what is SN1 mechanism? SN1 mechanism is what? That first of all, you are having some RX. Okay, some RX. So what is happening basically that the step number one, okay, that is a step number one is what? Formation of carbocation. Okay, there is a formation of carbocation and then there is a R positive form, right? This is the first case. And the second step is what? First step, formation of carbocation. Second step, that is addition of nucleophile. So nucleophile simply added here and we are getting simple. This is the observation. In short, that is there's a two-step reaction. Step number one, that is formation of carbocation. Step number two, that is addition of nucleophile. Okay, so this is basically the meaning of SN1 mechanism, and it is a two-step reaction, and the first step is the RDS step. Okay, it is a RDS step, means rate determining step. When a reaction follow more than one step, okay, so the slowest step is going to be the rate determining step. So it's my rate determining step, it means the slowest step. Okay, so it means the formation of carbocation is a rate determining step, of course. Now quickly recall the GOC. It means this is, if let's suppose this is my positive charge and this is my CH3, this is my CH3, and this is CH3. You know, basically there is a three, you can say, electron donating group connected. It means they are going to stabilize this. So means tertiary carbocation is more stable or the secondary more stable or the primary. That's it. This is SN1 mechanism. It means formation of carbocation is the key point. That's why we are checking for the stability of the carbocation only. But on the other hand, if we have to follow the SN2 mechanism there, so what is going to happen in SN2 mechanism? That first of all, this is some R. There's a some X group is connected, and the nucleophile simply attack here. So it's a single step reaction. Think about it, that this R is going to attack and this group is going to leave, so both step occur simultaneously. So if let's suppose we are using tertiary, okay, if let's suppose we are using tertiary there, so much hindrance. Think about it, if let's suppose I'm using this R, be like, let's say this is carbon and CH3, and you know how the three hydrogen look like. Actually, the structure of the carbon be like this, right? So if nucleophile attack here, so much hindrance. So that's why it's a single step reaction. One is going to add, one is going to leave. That's why we have to make sure that we are going with the primary, then secondary, and then tertiary. Okay, it's enough for the today's class. And if you want to understand in very much detail, please watch the recorded classes. Okay. So let's just back here. I hope this point is now clear. So let's just move where we are discussing all this thing. Let's back here. Okay, so I hope this point is now clear for everyone. Let's continue further. Now let's talk about the SWOT reaction. So the same SWOT reaction is very, very, very much important for the fluorine formation. Okay, look at this, that we are using some bromine, some chlorine, or some iodine, and then we are getting F. We can use any fluorinating reagent. Remember in the p block element we discussed so many times, this is behaving like a fluorinating reagent. So see this AZF, it's a fluorinating reagent. Yes, it's a fluorinating reagent. Okay, so it's a fluorinating reagent is there. And if you to observe that it is SbF3 there, and this is also COF2. Okay, these are some important fluorinating reagent. Add them and simply we're getting fluorine formation and AZPR release. Okay, this is all for the Schwartz reaction. Very simple reaction, only the naming reaction important. How the question asks what is Schwartz reaction, what is Frank-Liston reaction. And yes, in a Frank-Liston reaction it is important. Why that reaction is only for the NaI? Because answer is very simple. Na is soluble, but NaBr, NaCl or NaF is form precipitate. Okay, that's it. This is all for the case. Let's discuss about a question. Please answer this question, everyone. The synthesis of alkyl fluoride is best accompanied by which reaction? Option number A, option number B. Fluorinating reagent agent mean that is a fluorine donor. Fluorine donor, the thing which donate the fluorine. Okay. I guess it's easy. Okay. I guess it's easy answer. Sorry, question, right? B, B, B. Okay. Okay then. So yes, very good everyone. So observe this that a Frank-Liston reaction. No, we just discuss about it is for iodine, right? So iodine, it's wrong. So what fluorine? Yes. Free radical? No, no, it's not like Sandomir reaction. No. Don't worry, we will discuss about that reaction as well. What is the meaning of this word? Sandomir reaction. Okay then. So let's continue further. Let's see the one more reaction. In order to form the alkyl halide, there is a one more reaction is there, that is NBS. First of all, this is very much important. What is the meaning of this word NBS? NBS. Yes, please be noted. This is a note for you. When we are using NBS, okay. Now we are going to make some kind of notes be like, okay, write some important reagent. If this reagent you are observing, mark it at this is the important function here. Okay, do you know NBS is very famous for its free radical mechanism? Okay, it means if we are using NBS, definitely we are going to follow the free radical mechanism. Okay, so in this case this is important. NBS is famous for the free radical mechanism. It is really very much important there, free radical mechanism. Okay, so the point number one, free radical mechanism, okay, sorted. Okay, next, but what is NBS? Okay, I will tell you. It is NBS means N-bromosuccinimide. Okay, ma'am, we know, no, but what is this? NBS, any structure? Yes, there is any structure. Yes, of course, there is a structure for NBS. How about the structure is there? Okay, first of all, form a five-member ring. Nitrogen have to be there. Okay, you know the nomenclature that something if connected with the nitrogen, so we are going to use that is like this. Let me just okay, I'm sorry. Okay, see this. I hope now it's visible. So observe this, this is my NBS, and if let's suppose I have to put oxygen here and oxygen here, so this become that N bromo. First of all, observe that at N position bromine group is connected, so it's N bromo, and this complete group is known as a succinamide. N bromo succinamide. Okay, so basically what is going to happen in this case, in this case you have to use NBS. H nu, as we already know, if you're using light or heat, it is going to follow the that free radical mechanism, right? So in this case, what is the important point here, that if this is my CH3, so you have to check it for that position where the free radical is more stable. For example, like in this case, if you have to observe like how we are getting this double bond, and this is a CH2 radical formation, and then bromine is going to connect here, cool, it's simple reaction. Okay, but okay, wait, let's solve a question. Okay, so this is a question for you. Just try to answer the question, please. Okay, let's just use like this. In this, we are using NBS, okay? In the presence of light or heat. So there's an option for you. You have to identify the product here, okay? So what is the possible product? This is my question for you. Okay, what is the possible product here? So let's see. Options for you. Option number one. And in this case, this is only the bromine donor, okay? Be noted. Hmm. Yes, please. What is the correct answer here? A, B, C, or what? Okay. Okay, Jay. Is everyone? Please answer the question. Wait, Haju, wait. Okay. C. Okay. And now it's time to check it your GOC, right? Actually, okay, not an issue. Okay, we know one thing, everyone, right? NBS is going to follow that free radical mechanism. So there's a hint for you. Check it for stable radical with respect to the benzene. And if you're able to identify that, that will be the correct answer. Okay, so let's see what is the correct answer in this case there. So, okay, this is my benzene. There is some option for you. This is radical number A. Okay, this is radical number B or this is radical number C. So, which radical is more stable? Remember or not? But I thought when the radical combine at a benzyl position or allyl position, so isn't it the conjugation have to be there? Hmm? Remember that thing? We already covered this thing so many times that if there is a benzene, okay, if there is a benzene there and this is the carbon, okay, and if there is a radical, you know, it's electron deficient point here, okay, so it means this one has a vacancy, at least one electron, so yes, it can participate in a resonance. Yes, we know allyl radical, benzyl radical is very much important. So yes, the A is going to be the correct answer here. It means this is the correct answer here because this radical is more stable. Make a note, allylic benzylic radical is very much stable. Okay, I hope this question is clear. Okay, C, no, C is not going to be the correct answer because we know the radical stability. If you don't know, please revise the Lin class GOC. That tertiary radical is more stable or the secondary is more stable or the primary. And hey, C is going to be the primary radical. It's very unstable among all the cases. Okay, I hope the reaction part is clear. Which kind of question frame from this topic? Okay, so let's just back again. So yeah, okay, we are discussing not this. Okay, this here. Okay, so I hope this point is clear. Now let's continue further. Let's discuss about the second part, preparation of aryl halide. This is all for the preparation of alkyl halide. We discussed about this already. How to prepare alkyl halide from alcohol. There we discuss about a very much important point, that is Lucas reagent. If you don't know, again please revise Lucas reagent. Okay, then there we discuss further, we discuss about that eliminate that formation of dihalide. In the previous class we discussed about how the mechanism, there's a formation of cyclohaloneum and then a simple bromine, Marconic of addition. Every point we already covered, right? And now this is the second preparation, that this is all for the preparation of haloalkanes. Now let's just talk about the preparation of aryl halide, or you can say that is the haloarenes. So there is a two famous reaction here. The very first is the direct halogenation, or the second one is going to be the diazonium salt. Now the question be like, what is the meaning of this word direct halogenation? Okay, now my question for you, if let's suppose say that if this is the benzene, as we discussed already, right, and this is uh okay, OH is there. Okay, wait, chlorine is there. So is it really possible that you are using chlorine and reaction is going to happen? What do you think about it? No, right? Basically no, because benzene, you know very well, benzene don't want to lose its aromaticity, right? Benzene is already stable. But no, in 11th class we discussed about some reaction there, that if you are having benzene and we are having chlorine, remember that we discuss about total, you can say two, three type. Okay, that is one is chlorination, bromination, or nitration, and sulfonation as well. Right? One of the famous reaction, as I already told you in 11th class, this is going to be the very much important part of the 12th class, electrophilic substitution reaction. Yes or no? It's an electrophilic substitution reaction. Okay then. Then what does the second point we are using here? Yeah, we can use some kind of Lewis acid. Let's suppose AlCl3 there, and it is going to work. Okay, not very clear, don't worry. I will tell you the mechanism in a while. So first of all, what we are observing there, if you are using this, okay, so let's just discuss this here. Okay, so let's suppose if I'm having this is very much important part. There's a two option for you. This is my CH3. If I'm using chlorine, I hope now you're getting what I want to explain there. We are discussing what the chlorination, that is electrophilic substitution reaction, 11th class hydrocarbon. Okay, so this is chlorine. And if let's suppose we are using any Lewis acid, we can use FBr3, we can use AlCl3. Most of the time we are using FBr3. What is the reason? Because it's very simple, it is cheap. Okay, not very costly. Okay, we can't use AlCl3, we can use but not that much cheap like the FBr3. So Lewis acid, and we know the complete mechanism. First of all, generation of electrophile, then attack on a benzene, arenium ion formation take place, and then stabilize, and at the end that is remove a proton. Okay, I'm not going to explain all this thing to you. My question to you, that there is a some option for you. Just let me know which one is the correct option here. This is my CH3 group. Okay, condition number one, this chlorine connected here. Condition number two, this is CH3 or chlorine connected here. Condition number C, this is CH3 or chlorine connected here. Well, okay, three option only. So which one is the feasible answer here? A, does SOCl2 work? No, we can't use. Okay, because you know SOCl2 is important for the alcohol. If you are having alcohol and if you want to form the halogen, then it is important there. But here we are not having any kind of species as a lone pair. Okay, so SOCl2 we have to use only for the alcohol case. We discussed about SNI mechanism in the previous class, if you know, right? So follow that. So C. Okay, my question to you, why not A? Okay, Jatin, is the same problem with everyone? That I guess screen and everything is okay right now. Okay. Yes, please. My question to you, why not B? I'm not assuming like you are able to answer for the A, but my question to you is option number B is correct or not? And if not, then why not correct? No, I'm not using any light, okay? Come on, I'm using simple Cl2 and there is a simple Lewis acid. Okay, and we are going to follow the substitution reaction. Okay, so remember how to check it, yes or no. That first of all, this is what? This is my plus H group. Which kind of directing it is? Ortho and para directing. Remember that if CH3 group is there or any plus M or plus H group have to be there, we have to go with the ortho and para. So maybe the para product can be there and ortho can be there. But see, in the option we are not observing any ortho product, only para is there. So okay, this is the correct answer. Meta, this is not the correct answer. But why not A? Okay, yes, every time in a question you are having a trap. Why there is a trap? It is very famous question and asked so many times. If in the same reaction, if let's suppose I'm using chlorine in the presence of light, do you know what is going to happen? That a new thing is going to happen there, because we just discussed if you're using the same chlorine with the light, again it is going to follow three-step reaction. Remember, chain initiation, termination, propagation. It's a huge mechanism in 11th class. That, let me just quickly give you a brief. If you're using methane and if you're using chlorine, so we want only CH3 and X there, but plus we are getting CH2X2 there, and we are getting CCl4 as well, like this. That is mono, dia, tri, so many halogen formation take place, and it is a limitation as well, we know, right? But be noted, if we are using light, if we are using light, then for the same question, what will be the answer have to be there? Option number A is going to be the correct answer. Okay, just close your eyes and mark it, go with the option number A. Why? Because radical, we just discussed benzylic radical is more stable. Okay, so yes, yeah, these product can be there, but you know which we, what we are searching, the major product. Okay, so it's really very important. If the same halogen we are using in the light, so it become option number A. But if you are using Cl2, and sometime it is completely mentioned there, that is dark. Okay, yes, these there, the in organic chemistry, you know what is the good point here, that every time there is a hint, you have to search for those hint. Organic is not difficult, organic chemistry is very easy. But yes, that how to observe the thing is very important here. That's it, this is the important here. So let's just back again, and okay, not this slide. Okay, yes, we are discussing this. I'm sorry. Where's the slide? Okay, yes. Oh yeah, this one we are discussing, right? So observe this, that is, it's written Fe dark, right? Fe dark, and we are getting that is halo toluene or paratoluene. Now my question to you, which one is major here? Is it para or is it ortho? Okay, just for a while, if you don't know, be noted, right now para is major. Para is major. But if you are not able to identify para as major or minor, okay, don't worry about this. Again, we're going to discuss about this, how to identify. Just for this one only, that ortho position, there is a some repulsion take place, but at para, there is a no repulsion there, and it is going to be the stable product. Okay, it is going to be the stable product, or you can say major, just for this class only. But once we started with all the thing, okay, actually, it's not major. Okay, yes, there is a different mechanism and all this thing. We will cover everything one by one. But yes, technically, what is happening? Para most of the time is the stable one. Okay, and if you want to check it in a very much detail, go for the 11th class GOC chapter. I guess 14th or 15th. That before the that purification topic. Okay, that's it. Let's see the second preparation. Preparation with the diazonium salt. Okay. Now, what is the meaning of this word diazonium salt? Do you know the short form is also known as a BDC? Okay. So, what is the meaning of this word BDC? B for benzene, B for benzene, D for diazonium, and C for chloride. Okay. Yes, it can be any halogen, but most of the time we're using chlorine there. So BDC. So let's discuss about the this reaction here. That is from benzene diazonium chloride. So observe this. This is benzene diazonium chloride. How to form this? Basically, you will be having a amine. Okay, aniline, simple. It's NH2 and it is aniline. This is my aniline. And in the aniline, if you to add NaNO3, okay, in the presence of some acid, that is HNO3, 2 you can say, or 0 to 5 degrees Celsius. You know, in this case, the temperature have to be very, 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 very small. Okay, if you to increase the temperature, yes, we are not end up with a very good diazonium chloride. Okay, so after all these things, mechanism is important. Yes, it's not important here. In the upcoming classes, we are going to discuss about the mechanism part as well. So just simply, that is, there is a formation of N2 and Cl. Okay, N2Cl take place. Or how to represent this? That you can represent this thing be like, this is a benzene, okay, and it is N triple bond. And just because of the 3 4 bond on this nitrogen positive charge, in order to balance this, the chlorine behaving like a counter ion. Chlorine is not forming any kind of bond, just behaving like a counter ion only. Okay, and yes, if in this case, it is very much important, let me just explain this to you here, that if in a BDC or benzene diazonium chloride, this is BDC, benzene diazonium chloride, what we are discussing, triple bond positive charge, and this is Cl negative. Okay, this is my BDC, and in this, if you to use that is the Cu. Okay, that in this case we are using Cu to Cl2. Okay, you can go with the bromine as well. Same, fluorine, no direct formation, iodine, no direct formation. Because we know the issue fluorine is explosive, and we know the issue with the iodine because iodine is more stable in the form of I2. We already know all these things, right? So in this case, if you're using CuCl2, or you can use that as a CuBr2. Okay, this is very much important here. We are using copper salt. We are using copper salt here. Plus, HCl can be there. Okay, like this. So what we are using, that if bromine we are using, so bromination. If chlorine we are using chlorination. So it's a chlorination for the first one, and for the second one we are getting the bromination product. It means this is simple, bromine is there. Maybe chlorine, maybe bromine. It is a very famous reaction. The name of the reaction is what? Sandemeyer reaction. Okay, that is Sandemeyer. I don't know how to remember these things. Yes, but naming reaction is the very much important part of the organic chemistry. Okay, so that this is the name of the reaction. No, no, no. Okay, this. Sorry, where is the slide? Wait, wait. This part done. Okay, so this is when we are discussing, right? So it's a Sandemeyer reaction. But in the same reaction, if in the same reaction we are using only, it's very much important, only copper, no salt of the copper, only copper in the presence of some HCl or HBSA, so it is the same product we are getting, okay? That again the chlorine are connected here, but this is a different reaction. This is a different reaction. What is the name of the reaction? It become now Getterman reaction. It become Getterman reaction. So let me just explain how about the Getterman reaction there. Okay, so let me just brief what I just explained to you. If you have to use Cu2Cl2, we are getting this. If you have to use only copper and HCl, we are getting this still. But this reaction is known as a Getterman reaction, and this one is known as a Sandmeyer reaction. Okay, this is a difference. Yes, it's very much important that here you're using a copper salt and here we're using only copper. It's really very much important. Okay, that's it. This is all for the preparation of the haloarene one. Okay, so that's it. Any problem with the theory, please ask.
Ma'am, are we using HCl in Sandmeyer reaction?
Okay, HCl means that is it is being like a chlorinating reagent. Okay, acid. You can use acid or you can omit the acid. Okay, I want to explain the difference. Like, what is the difference? If you're using copper chloride plus HCl. Okay, or you can use copper plus HCl. Okay, so just got the point. HCl is a common thing and they're using copper salt and copper only. Okay, so it's optional for the Sandmeyer. Okay, then. So, yes, any more problem in a theory? Measure only light. Okay, I will ask you. Okay.
Ma'am, can you show the previous slide you used?
Mm-hmm. Actually, there is just so many slides. So I just confuse what I'm explaining. Wait for a while. This one, right?
Yes, ma'am.
Okay. So yes, that I'm explaining again. Listen, Hazio. I'm erasing all the thing. Okay. Let's just suppose if we are using. Okay, can you just tell me the common name for this one? What is the common name for this? Yes, very good, Hazio. It's going to be the toluene, right? It is toluene, right? Aditya, late. Okay. Okay then. So what we're discussing in this case, if I'm using that is let's see the common Cl2, Cl2. Okay, H2 means light. This side you can use dark. We can use any Lewis acid. FbR3 can be there, Fe can be there, anything can be there. Okay, any Lewis acid can be there. So what is happening in this case? This is CH3 and this is chlorine. It is para plus this is CH3 and the chlorine here. Okay, it's our ortho. So what I'm explaining to you, do you know in this reaction, yes, I know what is the answer from everyone and we already covered that is both are anti to one another. So para is going to be the stable one, right? Para is going to be the stable one. So according to student and according to the logic, major product is this para. Okay, Hasyu, but actually this is not major, this is major. Why this is major? Why all the thing here? Wait, okay, after the completion of this, again we are starting with like how to identify ortho directing, para directing, major and minor. So chlorine, yes, the chlorine can be the from the para one, but do you know chlorine is not that much large in size. Chlorine is very small size. So chlorine size is not that much large that it is it repel the something present at ortho to it. Okay, Hasyu. So this is simple that generally para, but here the ortho is the major one. So be noted, just correct this. That is, this is the major. So I just explained this point to you there that really this is the major product. Okay, and for the light part, if you're using a light, so basically we have to follow the radical mechanism here. So if you have to follow the radical mechanism, so definitely the Cl group is going to connect it here. That is, this is a CH2 and Cl3. Sorry, Cl is there. Okay, Hasyu, I guess it's clear now, right? Okay, so let's solve some questions only. This is all for the theory. Okay, so question part start now. Let me just check what we were discussing. This slide done. This slide done. Okay, please answer this question. Okay, let me just explain the question. What does the question want to say? Okay, question said that how many structure? Okay, this is some kind of structure is there. Okay, and if you to use some, okay, let me just explain on the next slide. Let's just erase all the thing. Okay, so that you will get a clear question like how the question asks. So this is a question. Okay, so what is the question? Question said you are having this CH3. Okay, this is a CH3 and this is some CH3 and this is my OH group. Okay, and here we are using some H positive and water molecule release and we are getting some F. Question said in the F, if you have to use HBr, okay, or yes, that Br2 CCl4, I'm sorry, Br2 CCl4. It's a Br2 and CCl4. So whatever be the product we are getting, the name for the product is this, that C4H5 and Br2, C4H8 and Br2, okay, H8 Br2. And basically we are ended with the five kind of product. Okay, so you have to identify how many stereoisomer is possible for F. Okay, and you know it's an advanced question. You have to identify the stereoisomer here for the F. First of all, yes, can you just tell me that if you are moving from this reactant to this F, which reaction basically we are going to follow? Options: elimination reaction, substitution reaction. Okay, yes, I know what is the problem with the student, ma'am. Theory wise, okay, but like if question is there, okay, it's very clear tree how to go, right? Okay, elimination, 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 but how to identify it is going to be the elimination, right? Remember, we discussed about this point already there, that listen my point. If you are using H positive every time, we know this thing, right? H positive there, oxygen has a lone pair, you know what is going to happen, it's connected here, and then there is a formation of water. And hey, in the previous class we discussed about this, that water is a very good living group. Okay, so you can say it's a CH3 and it is a CH3 and this is basically that is the living group, so it is going to live. So in order to some like you can say in order to stabilize this, we are having so many condition. What is the condition number one? That is maybe the cytosine be like I can go. Condition number two, okay, Maybe this hydrogen is there. No, it's not going to react because you know the elimination have to be alpha beta. Yes, please, Payal. Payal,
Slide is not visible.
slide is not visible. Just please refresh. Okay, everything is okay at my end. Okay, just please go refresh once. So
Okay.
yes, okay. What we're discussing basically that elimination, right? Okay. So you can see this is the carbon and it is connected with this water like this. And this is some carbon. So it is going to be the alpha, right? It is going to be the alpha and this is a beta. Remember alpha beta elimination. The first step is going to be the alpha beta elimination. It's a alpha beta elimination. Okay, then cool. So one more, this is a carbon. With respect to this, and please just be noted, the hydrogen have to be there. So with respect to this alpha, this is also the beta, right? If this is alpha, so this is beta. So technically we are having two kind of beta, one beta, right? So let me just highlight, this is one beta hydrogen and this is a second beta hydrogen. And now go for that and again identify the answer for this question. Okay, how many stereoisomer we are end up? Okay, just this is a hint for you. This hydrogen can participate or this hydrogen can participate. How many stereoisomerism we are going to get for it, this the F double bond? Okay, your time start now. 1 minute and yes, please answer the question. Three, two, three, three. Okay, see, I'm asking about stereoisomerism. So when the question came stereoisomer, you know, the first thing strike cis trans RS, right? Cis or trans. So check it for that. That where we are under with cis or trans, where we are not, right? Then you are getting a correct answer, absolutely. Okay, so two and three. So let's see what is the correct answer really here. So let's try to understand this topic. I'm sorry. Okay, let me just add one more slide. Okay. So observe this that if you are having a carbon, this carbon there, let's suppose this. Okay, let's just suppose this is my carbon, this is hydrogen, this is hydrogen, and this is hydrogen. Okay, let's just first consider if this carbon is going to participate, right? This is one more CH3 there. So if it is going to participate here, so you can say this bond here, and please be noted it's a water. Okay, so it's going to leave there. So what is the condition here? So we are getting that carbon, single bond carbon, and there is a double bond CH2. Okay, and just please connected some hydrogen, and this is a CH3 and hydrogen. Okay, so it means the condition number one, we are getting a double bond here. So you can say this is a product number A. Okay, and we just discussed maybe this can be the possibility. Maybe the side is an attack here, or this is the second possibility. So how about the pink possibility there that you can say that carbon carbon double bond like this, carbon and it is a CH3 and this is a hydrogen and hydrogen and CH3. So yes, everyone if you are saying option like 2 is the correct answer. So I admit like A and B. But question not ask about the product, question ask about the stereoisomerism. So my first question to you, in option number A, there is a any cis or trans possible? Yes, please, Payal, you can ask. But let me just first please finish the content. Okay then. Yes, there is any stereoisomerism for the option number A, A? No, right? Because we know the cis and trans condition already that if I'm using this word cis and trans, so come on, that look at this. If let me just write this, remember the very first condition for the cis and trans, the group have to be different and we are under with the same group. So if the group is same, so it means for this condition there is a no cis and trans have to be there. Okay, so let's just back here. In this case, there is a no cis and trans, so you have to count it. This is like a one. But no, for the option number B, a cis and trans can be possible because we are having different groups, CH3 and CH3. So yes, one is cis, one is trans. So what is the total counting? One cis, one trans for the option number B, and for the A, it is one. So the correct answer for this question is going to be the three. 3. Okay, so let me just back toward the question now. So what will be the correct answer for this question? Question ask about simply that in this case, what is this F? Okay, how many stereoisomerism possible? So you can mark option number D is the correct here, right? D is the correct here. Okay, now sorted. But my question to you, how to justify this? We are getting 5 product. How to justify this? We are getting 5 product. Okay, which kind of mechanism we are following here? Option syn mechanism, anti mechanism. You know, there is a formation of dihalide. In the previous class we discussed there is a formation of cyclohaloneamine. Okay, and then anti-attack have to be there. But how? If the stereoisomerism 3, then how we are end up with 5 product? Yes, optical isomerism can be there. Yeah, you are right. Anti. Okay, so let's find out the answer for this question, that how we are getting total 5 product there, right? So let's discuss about this question answer. I'm sorry, where's the slide? Wait, okay. Okay. So first of all, you are having cis, right? Double bond, CH3 and CH3. Okay. And this is hydrogen and this is hydrogen. So this is a first one. You can say it's a trans. Okay. There's a condition apply. First of all, you are having a double bond. Okay. Obviously, the bromine is going to attack. Maybe this bromine is attacking from the wedge position. Okay. This is a condition number one. Yes, this is still trans. Okay, or maybe this bromine taking from this side, and yeah, you can take hydrogen as well. So this is the product number one. Or maybe that no, this bromine taking from the wedge position like this. Okay, or maybe this bromine is adding from this side like this. Don't say, ma'am, isn't it the same? Okay, no, we are dealing with the stereoisomerism. We are not checking for the structure isomerism. So name is not important, rotation is important. Okay, it means for the option number one, we are end up with that is A and B. How it is a stereomer? Because all are the stereo, that is a chiral center. Observe this, this is a chiral. Observe this, this is a chiral. Observe this is a chiral, and this is also chiral. It's a homework for you. Try to find out the R or S. Is it A is R or B is S, right? So this is a simple thing. And similarly, for this one, you can say trans give two products. Similarly, that if you have to go with the cis give two product, right? That is maybe bromine above, maybe bromine below, or above below. But for the last option, if you're having only one single double bond there, okay? So in this case, there's a two hydrogen. So we just discuss if there's a two hydrogen, there's a no different kind of geometry we are end up. It means for the last one. For the last one, if this is my hydrogen, this is my CH3, and if let's suppose we are talking about the bromine, so it's a single one. Maybe this bromine is taking from the wedge position like this. Okay, and this is hydrogen, and this is CH3. Okay, this is hydrogen, this is hydrogen, maybe this bromine from this side. Okay, condition number one. Okay, let me just write decently so you are able to understand my point. You are having a carbon carbon double bond, hydrogen hydrogen, CH3 and hydrogen, right? In this, that if you to add the Br2, we're getting carbon single bond, this bromine at the wedge position, or this bromine at the des position, hydrogen hydrogen, or CH3 or hydrogen. Okay, condition number one. Or the condition number two, that this is my carbon, this bromine wedge position, or maybe this bromine des position. Okay, two product you can say. Similarly, if we are having a cis like CH3, again if you are at the bromine, we're getting carbon carbon double bond. CH3 is the same thing. Okay, maybe this bromine at the wedge position, or hydrogen, or this bromine at the disposition, and this is hydrogen. Or the condition number two, that or that carbon, I'm sorry, it's going to be the single bond. Okay, carbon carbon single bond like this, and it is a CH3, and it's also the CH3, and one bromine like disposition, and this is hydrogen, and one bromine like wedge position, and this is hydrogen. Okay, and for the trans, let's just back. Okay, I'm erasing this trans. So now my question to you, that A and B same or different? A or B same or different? Same. Yes, they are same. Okay, why they are same? Remember that these kind of thing we already apply in the chapter coordination chemistry. If you to observe that both cis CH3 are anti there. Here one bromine above, here one bromine below. Both are CH3 is anti, one bromine above and one bromine below. Don't say, ma'am, but cis the same thing. No, no, you can find the configuration here. That in this case, if let's suppose I have to write the numbering there, so it this one has a one. Okay, this one has a two, and this one has a three. If you to rotate the plane here, like it's we are getting 1 2 and 3. So which direction this is, ma'am? It is a, let's say, the this direction, anti-clockwise. S is the correct answer. But you are right, S is really the correct answer. No, see, hydrogen is not present at wedge position or at dash position. So it means in this case you have to count it both the cases like a different one. So be noted, for the trans both are same. For this one there is a two product. Don't say, ma'am, they are same. No, they are not same. Here two hydrogen with dash bromine, and here two hydrogen with wedge bromine. So what is the total counting? The total counting, that one, two, three, four, and in this case you have to count this is like a 5. So the correct answer for this question is the 5. Okay, so that's why that 5 product we are getting here. Okay, it's an advanced question. I don't know which year, I guess 2013, like like this. Okay, that's it. This is all for the question. This is all for the today's class. Done from my side, and please solve more question. And this question will be a homework question for you. Okay.
Ma'am, can you show direct halogen slide once?
Wait. Direct halogen which? Sorry. Okay.
Direct halogenation slide.
Direct, wait. Okay, this is HW for everyone. Okay, it's advanced question, same. In this case, if you add the bromine, so you have to identify the number of product. Okay, that how many chiral. Question asked about chiral. What is chiral? A carbon which is connected with four different group. Okay, four different group. We already covered all this thing in a coordination chemistry, if you don't know, right? So chirality and all this thing we already covered there. So direct halogenation. Okay, yes, this one.
Yes, ma'am.
Okay, Jatin, thank you so much everyone for joining the class. Okay. I guess Mohana, no. Okay, no one is taking, only chemistry teacher is free. Okay, they are taking classes. I know some chemistry teacher only, not math and physics. Okay, you can go. That is, yes, some there is some Hindi channel available. Okay, I'm not aware about the physics. Okay, so yes, this is all for the today's class. Thank you so much everyone for joining the class. Have a nice day, everyone. Thank you so much.